Hello, and welcome to Annuities and Loans, Part 2. Now we're going to talk about word problems. My name's Tuesday J. Johnson. I'm a lecturer at the University of Texas, El Paso, and an assistant professor at Doña Ana Community College. In our first example, this is going to take a few slides, so we're going to work through it. We use a couple of formulas. Your pension plan is an annuity with a guaranteed return of 3% per year compounded monthly. You would like to retire with a pension of $5,000 per month for 20 years. If you work 40 years before retiring, how much must you and your employer deposit each month into the fund? Now, as you read a word problem, there's a lot going on. And so you can see I've highlighted values in green and blue and red, and hopefully you can see the difference between the colors. If not, my son is colorblind as well. I apologize for always using green, blue, and red, but that's the way it goes, I guess. Here in red, we have our plan. Let me stop moving the words on you. Our plan. We want to determine how much you need in blue. This is what you want to happen. I want $5,000 per month for 20 years. Man, I'd like that now. Now, that's what I want to happen. I know what my interest rate is. And here's what I'm going to do to make that happen. I'm going to work 40 years before retiring so that this is my dream, this can happen. Here's what I need. I need to determine the present value. All right? I want to retire with a pension of $5,000 per month for 20 years at 3%. So I want to find out how much money do I need in the account to make that happen on the day I retire. Once I know that, in order to make that happen, I can use the PV from the ordinary annuity after I retire. And that's now going to be the future value that I want to aim for saving up in my sinking fund and find the payment for that sinking fund. Let's step through this one at a time here. If you need to, go back and check out the first video. It will give you the formulas. Now, looking at what we need. You would like to retire with a pension of $5,000 per month. That's my payment. For 20 years, the account is compounded monthly at 3%. So I have my ordinary annuity formula. I'm going to put in a little parentheses here that I just missed. I just noticed I missed. 5,000 is our payment, then the big fraction. 1 minus 1 plus 0.03 over 12 for monthly, to the power of negative 12 times 20 monthly for 20 years. Close the parentheses on the exponent and the numerator, divided by your I value. So I would like to retire. I'm collecting that $5,000, so I'm looking at a present value ordinary annuity. That tells me I have to have $901,554.57 in my account when I retire. So that's my goal. That's what I'm going to aim for. Now, I know that I'm going to work for 40 years before retiring. I have no idea how much I need to put in the account, along with my employer, in order to make that $901,000 happen. So let's find the amount of that payment. Looks like I'm really good at forgetting parentheses. Let's throw in another one there. We know our future value. We know our years, we know monthly, we know 3%, we can find I, we can find N, we have a future value, let's find the payment. We're going to find the value of the big fraction using the sinking fund, right? Sinking fund because we're saving up, so it's the one where 1 plus I is positive, the exponent is positive. Don't forget your minus 1, close parentheses around the numerator, divide by I. I found the value of my big fraction to be 926 point stuff, again the technical term. To find the value of the payment, $901,554.57 that I want to have after I've worked, divided by my 926 number, gives me payments of $973.54. So, in order to collect $5,000 per month for 20 years when I retire, I have to deposit $973.54 into the account each month for 40 years. Now, hopefully I only have to pay half of that and my employer's matching it, but it depends on where you're employed. All right, here's an example I've actually used in my real life. While shopping for a car loan, you get the following offers. State Savings and Loan is willing to loan you the $10,000 at 9% interest for 4 years. First Federal Bank and Trust will loan you the $10,000 at 7% for 3 years. Both require monthly payments. But you've looked at your budget because you're a responsible adult and you know that you can only afford $250 per month. Which loan, if either, can you take? So we want to decide which loan we should take that fits our budget, but also how much would you actually pay for the car with these loans? So $10,000 car loan, how much would I pay in total for the car? Let's start with First Federal Bank and Trust. 10% at $10,000 at 7% for 3 years. So I have my present value, my I, 0.07 monthly, divided by 1 minus 1 plus I to the power of 36, negative, right, because it's a loan, negative action, negative 36, close all my parentheses. And I know that First Federal Bank and Trust, my payment will be $308.77. That's not in my budget. But if I pay $308.77 every month for 3 years, I end up paying back $11,115.72. All right, a little over the $10,000, but that's what happens when you need a loan. State Savings and Loan is willing to loan you the $10,000 at 9%, but for 4 years, monthly payments. So the $10,000 and my I value, 0.09 over 12, divided by parentheses around my entire denominator, 1 minus, parentheses, 1 plus I, to the power of negative 48, right, monthly for 4 years. This payment is only $248.85. It's on the upper end of my budget, but I can afford it. I could not afford that payment that was over $300 on the last slide. Here's the difference. Yeah, you're paying less each month, but it's for a longer period of time. So you actually end up paying more in the long run because you can afford the payments in the short term. So, while shopping for a car loan, you get the following offers. State Savings and Loan, the payment's $248, which is affordable. First Federal Bank and Trust, unfortunately, is not. All right, our last example of this type. Suppose you inherit $10,000 when you're 35 years old, and you use that to start your retirement account. Because you're 35, you're thinking, I don't need retirement, and then it hits you. I have a family. I don't want to work for the rest of my life. I kind of like to enjoy grandkids if I happen to get grandkids. So you use this $10,000 and you do the responsible thing and you start a retirement account. You then deposit $150 per month for 20 years at 3% per year with monthly compounding. All right. How much would you have in total at the end of those 20 years? Let's take a look at this step by step. Suppose you inherit $10,000 when you're 35 years old and you use that to start your retirement account at 3%, 30% would be awesome, 3% interest monthly. At the end of 20 years, notice this is a lump sum deposit. This is $10,000. It's not a periodic payment. It's, here's a bunch of cash, I'm going to put it in the bank. This will be compound interest. The compound interest formula is FV equals PV times 1 plus I to the power of N, or MT. So the $10,000 is our present value. That's how much we have. We're going to put it in our account. We're going to make this happen. Parentheses 1 plus I, 3% is 0.03. Monthly is divided by 12. To the power of monthly for 20 years. That $10,000 after 20 years has now grown to $18,207.55, which is pretty cool on its own. But we did more. Now that we have that amount of money saved in there, we also start depositing regularly, $150 per month for 20 years at 3% per year with monthly compounding. And I want to know how much I have with those regular deposits after 20 years. Well, a monthly deposit is a sinking fund, so we find our sinking fund formula. I want to know my future value. Payments of $150, numerator in parentheses, parentheses 1 plus I, to the power of N, also known as M times T, monthly for 20 years, come out of the exponent, Subtract 1. Notice I use parentheses in the exponent because there's something going on. Make sure you close off the parentheses around the numerator before you divide by I. And just with those deposits, you'll have $49,245.30. Not bad. But remember, in total, you'll have the compound interest from the $10,000. You'll have the sinking fund, which is a type of annuity, of $49,000 from your regular deposits. So now this account will have a total of $67,452.85. Not bad. Of course, you'd want some more money. That $900,000 that we looked at would be a great retirement fund. I wouldn't mind having $5,000 per month for 20 years. And I have to make sure I retire late enough that that's going to last me. You retire too early and you're going to be back to work. Nobody wants to go back to work unless you're one of those people that get bored. That's it for the word problems. There were only 3 of them, but thanks for listening anyway.